Happiest Minds, we are the team specialized in search technology development. We use Solar and Lucene Core APIs for search applications. And also in the past, I have worked on content management systems development and e-commerce website development that had search as a main feature and Solar as a search engine. So today I'm going to talk about document level security in search-based applications. So the agenda for the presentation is the following. First, I'll be introducing you guys to search-based applications, and then we'll try to understand what is document level security and why is it required. Okay, following to that, we'll be discussing on access control list that enable security features, and we'll discuss multiple solutions pertaining to the topic. And finally, I'll conclude with summary of lessons learned. So, any software applications in which search engine is a core infrastructure for information accessing and reporting are search applications. So we use semantic technologies for information aggregation and classification. Okay. For example, all e-commerce websites which we use for online shopping, and also content management systems that we see in our organization or in universities are the types of search-based applications. Okay. So in the pictorial representation, if we start looking from the bottom, so we see the data storage layer, that is the volume of data aggregated from different repositories like archives or documents, databases, file servers, emails, etc. And then we see a search engine that indexes content from this data sources. So these two are the very important component in any search-based systems. Okay. So further, we see a search application server that presents user with a graphic user interface to interact with the search engine to retrieve search results or to upload any document, and that goes and sits into data storage layer. So basically a graphic user interface. And the top is a user authentication system that is not a mandatory system component in all the search-based system. So we don't see it in many e-commerce websites because it gives access to public users. But in any content management system, we see authentication system. Okay. So we have everything in place. We have authentication system that challenges for user identity. And also we have a Solar search engine that enables searching and relevancy scoring, ranking, everything. So still we have a problem in the system. So now let's see what is the problem. Okay. So the problem is in the common access given to the unified data layer. That means the system doesn't differentiate between the users. When any two users comes in and searches, the system doesn't differentiate the results it retrieves. It gives a common access to the search from the search engine. Okay. Okay. Let me try to elaborate the problem by taking a use case. So let's consider that user A logs in into application and he performs a search operation. Also, let's consider that the user is a new user to the system, so he wants to know about some appraisal standards in his organization, and so he starts searching with the word appraisal. A common keyword, like we start searching, we use with the first keyword that comes into mind. So let's see the demonstrated search result. Okay, so we see the first result, which is exactly what the user was looking for. It talks about some appraisal month for this year. Okay, so that is relevant result and a correct result. But the next result, it talks about performance bonus for RDAC team and -customer appraisal. That is related to some team and a customer appraisal. It is a confidential information of the company. So that should not have been retrieved to the current user, though it is a relevant search result because it has word appraisal, but it is an unauthorized information given to the current user. And also we see the last one, we see my appraisal not evaluated correctly. It's some other user's email or document that is again a unauthorized information or confidential document of other user, but is being retrieved in the search because as we saw that the data layer is not differentiating between the users. It is retrieving the same results. Okay. Now let's summarize the observations. So the observations were user was retrieved with the relevant search results. Those were correct. but he was also retrieved with the unauthorized search results. So that was the threat. Okay. So the threats were exposure to other users' confidential information and also access to unauthorized documents. Okay. So we now understand what a search-based application and where the threat exists in the system. Okay. So now let's spend some time defining the problem. Okay. So the problem is to develop a search platform where every user has access to only those documents to which he or she is authorized to view. Also to ensure that all the confidential data uploaded in the system are not globally searchable unless it is intended to globally accessible. Okay. Fine. Okay. So now we know the problem. So how are we handling it? So we handle it by maintaining access control list mapped to each document object. And what are these access control lists? These are the mapping between user space and the document space. That is, mapping indicates list of user who can access a particular document. Okay, fine. We'll define what are access control lists. Access control lists are the security feature that control how user and document should interact with each other. Okay, so user becomes a active entity because it requests for the access, and document is a passive entity because it contains the information. Okay, so now we understand what a search-based application, where the threat exists, and how are we handling it is by using access control list. So we have to fit this into a search engine. So let's see the data model of the search engine. Okay. So the data model of the search engine, I think we might be knowing that we use document-oriented approach in any search engine. So what is document-oriented approach? That is, the information of the document and the metadata is extracted and put into a flat structure called document entity. Okay, so whereas in case of relational database, if we have a new array, we put it into two different tables, we use joins, we normalize the data in relational databases. Whereas in case of document-oriented approach, we try to denormalize the data. We try to put everything in a single document entity. Correct? Okay. So using this model, we have to put access control lists to each document. Okay. Just an overview of indexing, how indexing takes place. So when a user uploads a document or a document comes into the system, we extract the metadata and the text information, and then we convert it into standard format like JSON or XML, and then we import it to search engine. Okay, so in this process, we actually miss to capture something. So what is that? That's the user level information, as in who uploaded the document and to whom did he share with. So using that information, we build our access control list. Okay. So now we know that what a search-based application where the threat exists, how are we handling it is by using access control list, and we will be putting that in the search engine. We use that is Solar. Okay. Now we will see the conventional solution for this. So the conventional solution is whenever the user requests, does a search, we pass this query to the search engine and search engine retrieves the set of documents. I think, yeah. The search engine retrieves a set of documents, and then we apply here access control list. That is, we filter each document, we iterate through each document and then check whether the user has access, and then we finally return the results to the user. So this is the conventional solution. Now let's look at the multiple solutions to handle the same conventional solution efficiently, as in less memory overheads and also the less time delay. Okay. Now, the solutions are again dependent on the access control model we choose and also the type of systems. So, first we have two different types of access control models. One is non-discretionary type of access control model, and the other is discretionary type of access control model. Let's look at each one separately. Okay. So, non-discretionary type of access control model is a role-based type of model where every user is assigned to a particular role. Okay, so we call this as non-discretionary because every user has to be assigned to a certain role. There will be no user who will not be having a role. He does not exist like that in the system. Okay, so So we might have seen such system in our organization. We have a group of people working in sales department, and also few group of people working in as an engineering team and development, etc. Correct? So based on that, we differentiate the users. So we have in the pictorial representation, we see we have a user sales. So that he's belongs to a sales team. So he is given access to only sales document. And also then we see manager who manages the infrastructure. So he has access to search documents, sales document, and as well as engineering documents. And also there is a super user who maintains the entire system. So he's given access to all the documents. Yeah. Okay. So this is the role-based type of model where we differentiate users based on the roles. So solution for this role-based access control type 1 is, if at all for the system, the roles defined are at design time and they never change. So static access control, then we use early binding approach. So I'll be explaining in the next slide what is early binding. Here, what we can do for such system, what we can do is, at the time of indexing, with the document entity, we also pass the list of role IDs who has access to the document here. Okay, so this becomes again a denormalizing way of denormalizing concept. So we add all the role IDs and then we index it into the Solar search engine. So this role ID becomes a multi-valued field, a list of integers. So at the time of search, what we do is, based on the current user who is searching, we also add the role ID of the user, and then we get the query response, because search engine internally takes care of to filter out the documents. So we can use Solar filter queries to filter out the document. So this model you see here in the red is called early binding, because at the time of querying only we add the user role ID. Okay. So what happens in late binding is, after we retrieve the search results, we then apply the filter, as we saw in the conventional solution. That is one way where we apply filter later. So that we call as late binding. Here we call it early binding because we are adding it with the query request. Okay. So this is again a simple solution. It is only for such systems that have roles keep changing. I mean, if we have a system in which roles keep on changing very often, that time we would have to normalize the data. We would need to maintain different access control list in a different document, so that if we have frequent changes, we only index that ACL document and not the entire document. So re-indexing the entire document, we might lose data or any other inconsistencies can happen. So we normalize it using the primary foreign key relation. More like that. So we use a Solar pseudo-join utils for that. There is a link for pseudo-join utils. We can follow that to have this approach. So such systems are very rare, but if at all we have, then we have to follow this. We can follow this, sorry. Okay. So we'll go to next type of access control model. So this is a little complex model. It's a discretionary access control model. In this, every document owner has given an authority to set the permission, correct? So we see in the pictorial representation, he's a document owner. He'll set the list of users who can access this object. So in that case, every document which comes in into the system has its own access control list. Okay, so we call this as discretionary because user has control to set the access of the document. Okay, so we'll see the solution type 1 for this. Okay, so this is for systems that have frequent change in access control list. Okay, which means that a document owner who sets the permission today might change it again in the next moment or any time. He can keep on changing. So for such systems, we will have to maintain each document list of users. We would need a 2D matrix representation that will have every new user added as along the row wise, and new document added along the column wise. So 0 stands for user has no access and 1 stands for user has access. So if we see user B document 1, he has no access, and user A document 1 has access. So we would require such 2D representation to have access control list in the system. Okay. Now let's elaborate the solution by taking a First is for implementation, this ACL matrix can be represented as an array of bits, which means that we have all the values 1, 1, 1 and 0. We convert it as a stream of bits. For every user, it becomes a stream of bits here. So for all the set of users, it becomes an array of bits. Okay. This compaction is for improving search efficiency as well as memory overhead. Okay. So now let me explain with an example by considering some assumptions. Like so we'll consider that maximum document in the search systems were 5. So the document ID is an incremental counter, that is 1, 2, 3, 4 and 5, and also the maximum users are 2. So that is user ID 1 and 2. So if we see here in the table representation, we see here, so user 1 we'll consider that has access to only 3 documents, 1, 2 and 3. So we go to our matrix, we say for 1 he has access, 2 access, 3 access, and 0 and 4 he is no access, so we put 0 here. Also for user 2 he has access for 1, 2, 3, 4, 5, all the documents. So we again set all the positions here, 1, 1, 2, 1. Okay. So now we see the array of bits here. So it becomes 1, 1, 1 and 0, 0. So likewise. Okay. So now we are left with only the array of bits. So this is what we'll be handling for the implementation. Okay. Okay. So in Solar implementation for this, a solution type 1, we have a post filter interface in Solar that can be utilized to develop a custom plugin. This Solar post interface has one method called collect method. It has list of document that match. It will be having the list of document matched to the search query. So we iterate through that and then use this array of bit to check whether the user has access or not for all the matched documents. So this is a kind of late binding approach, but we are not retrieving all the documents from the search engine and then doing a filter. Instead, we are putting the same late binding within the search engine. So it is not exactly late binding, it's a pseudo late binding kind of thing. Okay. So this is one. And the other implementation is using the bit set utilities. So if we can get the bit sets of the document matched by the search query from the search engine, and also we'll already have developed the bit set for the based on access control list. So we'll plainly do a logical AND operation and then we get the list of documents matched to the current user. So we can put this system in the Solar search engine by having a custom plugin, and then we will have an efficient way of handling it. Okay, so this is not implemented already, so it's in my current project. So as soon as I do it, I'll be hosting it on my Git. Okay, so this is a final solution type 2. This is again for discretionary access control systems in which the ACLs remain static. So once document owner sets the access control list, they remain static. They never change in such system. Again, these systems are rare. If they give document owner permission to set the ACL, he might change. So we would need to give that functionality. But still, if we have such system, then the approach is so the approach is here. At the time of indexing, we pass the document and also add the list of users who has access to it, and then push it into search engine. So we have a multi-valued field for list of users. Okay. So at the search time, we simply add with the query request, we add the user ID and then we pass it to SolarJ client. It will return the list of results as a query response. Okay. So this is again a denormalized way of handling it, and as we saw this similar approach in role-based access control. Okay. So the summary is discretionary access control list that we were talking about with late binding solution is a complex model. It means that we have to maintain access control lists outside the system, and it's also in the bit format. So it requires extensive verification. It requires a lot of additional interfaces and also batch jobs to keep the process updated. And also we might have challenges in near real time permission search, all that. And the Solar smart caching capability is For the non-discretionary access control, we saw denormalized methodologies. For that, we would require to see Solr caching. We have a lot of caching features in Solr, like document cache, field cache, filter cache. Main important is filter cache. So there is a blog by Eric and one more. I don't know. I don't remember the name. Sorry. So we can follow those blogs to actually have advanced caching filters. And the final is ACL always adds additional overhead. So it requires optimization to provide the minimum delay. Yeah, so these were the references I have taken for this. Yeah, so thank you. This is the end of the presentation. Okay, so any questions?
Using the pseudo join approach, you can have a Solr core.
Okay.
Where you index your ACLs.
Okay.
This core usually is quite small compared to the other core where you index the document. So it allows you to change ACL quite easily.
Okay.
The approach you propose, the matrix approach, is it very advantageous compared to this to the pseudo join approach when I don't know when the ACL are changing frequently, the permissions are changing frequently.
Okay. So correct me if I'm wrong. You meant to tell that we'll maintain those 2D metrics in another core of Solr, and we use a pseudo join to find the user.
Yeah. What I do when a user makes a search is find. I have a user who belongs to a group, for example, marketing. I search in the ACL core which ACL is allowed to, and then I join this ACL with the document core where I have the ACL indexed together with the document, so join with permission and then filter with the search parameters. So I have documents with ACL metadata, and ACL don't change when the user group change or things like that. So they are quite static, and this allows me to manage a dynamic environment where permission on documents change a lot.
Okay.
So I was thinking about this scenario when I wanted to implement something with Solr. So this methodology is new for me, what you're proposing now. And I was curious to know the advantages.
Okay. As in I have not used pseudo joins in the past implementation, because when I had taken stats for pseudo joins, it gave me a lot of delay. Comparatively, every time when I use pseudo joins, not pseudo joins as in where I used Solr 1.4 version, that time we didn't have joins. So what we used to do is we had two different cores. We maintained it in different. So first, different ACL, access control list in different Solr index. So we used to first query that index and get all the list of IDs which user can access. And then we used to get the results. So that was a kind of pseudo join, what we called. So internally right now, Solr new version is handling pseudo join. How it is, I'm not sure. But when we use that approach, we had a lot of delay because it was too query to the server. So first query was to get all that and then filter it by that.
Thank you.
Yeah, thanks. Okay.
How's the bitmap for the documents at the level of user updated when new documents are indexed?
Okay. You mean to tell it's in the real time case?
The example when, at the level of one user, you have a long bit array with the IDs of for all the documents theoretically. That's how the matrix looks here.
Yeah, correct.
So that you said it's kept in memory for the
active users.
And not the users.
Yeah, correct.
But at the same time, new documents come in unindexed, and therefore some of these document users gain the right to see them. So that bitmap is kept in memory has to be updated.
Yes.
some.
Correct.
So how that?
Okay, that is a batch job which is running that will keep updated. So once that is updated, so we also refresh that in the memory. So it's a cron tab. Yeah. So for that bit, we keep checking for that bit if it is set or not, and if we have to set it, we do, and then we update. So it's always a 3 minutes delay. If a user changes the permission, so it's a 3 minutes delay. It's not real time exactly. Yeah. Thank you. Thank you very much.